Okay, so this is our highlights class for the lecture from Design 301 on June 15th for the summer. We just went over some notes on multiple submittals, file submittals. If you have problems with that, you can get with me. What we're going to go over is a demonstration of plate number 4, some alternate methods for plates 1, 2, and 3, and then just some questions and answers which you may have. So feel free to jump in for those of you that are on with us, but we do have the recording going. And so here we go. Let's take a look. This is what I'm going to draw. So that's what I'm going to, no, that's not what I'm going to draw. I'm going to draw what's on the Jamboard. That's what I'm going to draw. That's your plate number 4. And again, oh, so many ways to do this. Tons of ways to do this. And I'm just going to happen to pick one of them to do. Okay? So what I've chosen to do is to draw the outline because I'm given that information. And I know some simple tools. So if I draw 2.5 over, and then if I draw over 1.25 and up 1.25, I can do that. And you recall that there's a couple ways I can do it. I can draw the lines and connect them, or I can draw plus 1.25, comma 1.25, and then I can draw up 2.5, and then I can draw, again, this says typical, TYP, typical, which means all of the corners are like that, everywhere that you see that. And so I'll come back 1 and up 1.25, back 2.5, back and down 1.25, down, and then I'll close. And then I see this, which tells me that this is an offset. And it doesn't really tell me. And so this is not really a great drawing, but I'm going to make a guess that this one, and this one are the same. So if I can just offset those lines, then I can use my O snaps to match those and then just draw these. So I've got a lot of drawing, but that's cool. So that's what I'm going to draw first. I'm going to draw cross. Let me make that thicker. I do have a Wacom pad with a pen, and I draw much better with it, but. So I'm going to draw that first. Then I'm going to offset these lines. And then I'm just going to connect things up. And that's going to be my first set of stuff to do. So there's my snip of this thing, so I can put it into AutoCAD. Maybe. This may be in a different one. No, that should be the right one. There we go. And you get better at this as you go. It gets more and more common. And again, this one doesn't tell me a start spot, so I can just go to 10, 7.75. And I can move that. And I'm a typer. Did you see I didn't go up? I just typed M, enter. That's just how I learned this stuff. Okay, so here we go. I'll start somewhere and I'll go over 2.5. Then I'll go 1.25, 1.25. I'll go up 1.25. Now this one, I know that that's polar tracking, and there are some cool things I can do. Watch, I can set my polar. What? Well, no, I'll come and do that later. Never mind, I'm getting ahead of myself. So I'm going to go minus 1.25, 1.25. Minus means backwards. I got that all messed up. Let me do it right. Goes up 2.5. And then minus 1.25, 1.25. Minus means backwards. Plus means upwards. Now this one's going to go backwards and down. So minus 1.25, minus 1.25. And I obviously typed that wrong. So let me go back and do that again. Minus 1.25, minus 1.25. There we go. Now I've got that offset command again, which is really cool. Okay, Anna, we'll see you back in just a minute. I'm recording it, so don't worry. Offset 0.42. And I'm just double clicking the enter. One to exit and one to redo the command. You can probably hear me punching the keypad. So now I've got all that done. Let's go back and see what's next. These ones are midpoint. Now I don't have a real offset. I just know that these ones come down 0.42. So that's not an offset. So I have to draw this outside, draw some lines, and then connect these up. So I think that's the way I'm going to do it, because I don't know what this offset direction is. I know this straight line, and that's not an offset. But I can go from midpoint to midpoint. So let me make sure I've got midpoint is set. And see, it just shows up as a little triangle. And then we can go to, and I'm telling you, there are lots and lots of cool ways to do this quickly and easily that is much faster than this. Now I've got those. Now let's go look my last little piece here, and I'll make this. I haven't done red for a while. I have a box that goes from this midpoint to this midpoint. It's a rectangle. And then I can offset at 0.42. And then I can get these. So I think that's what I'll try. Seems like a cool way. So see, this is a box, a rectangle, from the midpoint to the midpoint. And my offset is 0.42 to the inside. There we go. And that looks pretty darn good. I think I did okay with it. Okay, so that's one cool way that you can go about doing that. And it didn't take a lot of time. Let's see if it comes up on here. What's my latest current time? It looks like it's not saving this session because I've had it open for a long time. Okay, that didn't take too long. Okay, any questions on how to do plate number 4? Okay, well there we go. That's pretty straightforward. There's a few things you might go, I wonder if I got my dimension right. There's a cool command, and you can dimension it and stuff, but there's a command called measure distance. And I'm a typer, and I can never figure out where it is. So I just type DIST. And I'm going to measure a distance. And I can measure from one point to the next. And you see how it gives me that 5.0? And here it even tells me in that box. Let me do that again. It tells me, I keep getting it. There it is. It tells me a distance in the X, in the Y, in the Z, and a total distance. So that DIST command is really nice for taking a quick check. And then I can also drop down here. Oh, yep, that's 2.5. How about the distance across there? 0.42. So it's a quick way to check your work without having a permanent record of it. So the distance command, DIST, is pretty cool. And there are other measure commands that work pretty nicely. Okay? So that's how you can check it against this. There are other ways to do it too, but this is a good time to show you that. Actually, I think here it is over here. That's probably the distance command. Isn't that cool? That's not telling me what I want. That one is. That one is. Tells you all sorts of cool stuff. So this little general measure command is pretty cool. It kind of picks up a few things. And look, remember we were talking about whether it's a true right angle or not? Way down here in the corner, you see a little right angle symbol. So it's trying to give you angles too. So that little measure command is kind of cool. You don't have much control over it though. Okay, any questions on this plate? Okay, well let's see if there's another way that I can do this. So I see down here, and this is just going to throw you a bunch more cool commands just to show you. You're not supposed to learn these other cool commands just yet, but it's kind of cool. So I think I could make a 5 by 5 square. Oh, that on? Yes. Oh, that's right. And I can do something called a chamfer. Now, the chamfer is kind of like a fillet. Okay. And what I'm going to do is I'm going to pick two distances. And the first one's going to be 1.25. And the second one's going to be 1.25. And then I can pick two edges and it will chamfer them. So that was a little bit quicker than drawing all those lines. And now you'll notice this is all one thing. Let me see what happens when I do an offset of 0.42. It doesn't really quite do it right. So you see? So that's something to think about there. Okay, but what could you do? You could draw a line. Did you see why that wasn't quite right? Because it's trying to do some weird thing to do it all. Did you see what I just did there? It's called snap reference lines. So if I know that that's coming down, I can find these other points. Oh, that's a quick way to draw. Doesn't do it on this funny angle because it doesn't know where I want to go. Now check this next one out. This is that polar array thing that we're going to go over later. And I'm going to pick the geometric center here. And I think there's 4 of them. Isn't that cool? Except I got something a little bit wrong with this one. That's telling me that I didn't quite get that one right. So I better get this all right. Actually, let me do a different one. I'm going to do one called mirror because that's a fun one. And it's used a lot. There's my mirror command. And I can mirror about a center line. That's kind of cool. And if I draw that line, I can mirror again about a center line. So that can be a quick way to help you from having to draw a whole bunch. Draw a little bit, mirror, 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 mirror. Or, let's see, I should be able, 1, 2, 3, 4. Let me get rid of some of these. And that array command should work. Let's try the polar array command. And pick 4 of them. That works better. So that's another way to do it. Not a cool thing? So you can mirror, you can array, you can make this all one thing and do chamfers. Lots of cool things to do there. Now on this one, I can take that same idea and draw 0.42, draw 0.42. And I don't know if you think this is quicker or not, but some people might. And it depends on what you need to do. And maybe you want to do a mirror command of those. And I think this one was pretty straightforward. So those are all cool commands that you might like to play with as you go along to see if you can get things just a touch faster. And it's kind of up to you which of those might work. The chamfer command is kind of cool when you're doing mechanical work in Inventor. It actually notes it for you. It knows what you did to make it, so it tries to add that to your drawings, which is kind of a cool thing. This is kind of nice because there are things you can do if you have to work with specific features of it. So those are some cool things that you can do. Okay. Does anybody have any? Let's see. What are some of these other ones that you might think about doing? Let's try this one because we talked about making this shape and then trying to maybe like rotate it and copy paste it and stuff like that. Let me see if I can figure out how to do it. So this is a square that's 1.14 and it's offset 0.38. I don't usually do it this way, so let's see if I can do it. And this is going to go off. And my trim, do I have that right? Sort of. That looks pretty close. Now the next one looks like, does my next one even match up with that at all? No, it's this one over here. And this one is totally different, right? Man. I can't even tell. So that way isn't, yeah, that's just not even going to work. I really think that this one is the brute force method. Do any of you see a pattern there? I've done this for years. I really don't see a pattern to it. I have seen people make these and set a pattern to it. Yes. So that's a great question. Can you use the trim command on parts of an array? So let me come over here. Did I do an array on this one? Yes. So let me do one. Let me just make an array of that. And you go, okay, I want to trim some of this. And you go, and it says, no, 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 no. It's because it's memorizing this piece and you can't fix that. So you have to explode the array and then you can trim. Okay, so that's sort of what you have. Yeah, it's like, oh, really? And that's just that's because that's how AutoCAD keeps itself down. So AutoCAD has, I think, a limit of something like 12 million discrete object vectors that can be held in it. And so now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, da, da, da. So I've got a lot of them here. When it was an array, it had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 little bits of information. How far apart are they that way and that way? And it uses that to regenerate. So you can have massive numbers of stuff when you use the array command that you cannot have when you explode it. And if you've got a big file, that's a big deal. Okay, so that was why that happened. So when I first learned AutoCAD, we had these things called floppy disks, and they held 1 kilobyte. Oh my gosh, they were massive. But we had to do something called purge every drawing to get rid of every literally bit of information that we could get rid of, so that our files fit. This file here would have never fit on a floppy disk. And so that was one of the ways that AutoCAD came up with, literally years ago, to keep file sizes small. But it's really a great tool. So that was a good question. Thank you for that. Any other questions about how to's, or what should it look like? What can I do? So I've got my favorite ways to do these. You're welcome to do them in any way you would. Like this one, I've seen people draw this and array it around the center. Personally, it's not intuitive to me. Because then I have to find the center, which is over 0.25 and down 0.25. I think I'm going to need part of that. So when they do it different. I can, and I'm not positive about that, but I think that's where you go. And then you can draw over uh, 0.5, no, over 0.25. So this is not intuitive to me, but I have seen people that just like this is their thought process, and it's perfectly okay. Pretty cool, huh? So you can see that that is pretty quick. So if that's sort of your thought process and you saw that, that's a pretty quick, cool thing to do. Um, so I wanted to show one of you, I don't remember, somebody in the class is a fountain person. And this is typical fountain type work. So I'm going to put this into 3D mode. And we'll pretend that these units are feet now. And one of the things that people do is that they press pull different things to be different. This one should have been that. But now you can see that with just a little bit of work, you can make these feed one to the other, right? Just a little bit of work. You can have a nice overflow to here, back into the midpoint, into here, into here, into here. Basically, your insides need to all be at one level in the middle, and then these can all feed out into different levels and feed into one that's further. So this is a very typical way that you can take a simple geometric shape and turn it into kind of a cool fountain type thing. You could even let me do a quick offset on that. So you can see these all have a place now to drain, and you can just set up where you want your fountain outlets to go. So from this, you've got a really nice kind of cool fountain thing that is easy to take care of. You can do all sorts of work with your surfaces to make them how you want. And so you've got a very nice, simple fountain design. I don't remember. Noor, was that yours that you talked about the fountain? Not really. I'm not remembering all the way. But this is how you can quickly and easily. Oh, it was Anna. Anna. Okay. Yeah. There we go. So this is one of the ways that you can quickly and easily work with it. And I actually did work for as a contractor designer, a pump designer for somebody who did this kind of stuff. Playley Architects in Davis. And of course, their difficulty was what happens with the cigarette butts and the leaves and the just garbage that people throw into these things. So my job was the filtration side, and then they wanted to avoid chemicals, to keep these things clean and free of just algae and ugly, gross stuff growing on it. Most places use chemicals, but I had some experience when I was in college with biofiltration. So I worked with them to put biofiltration units on these. Sometimes they put these as main water features in a house, and they used some evaporative cooling where they would let these things go down into coils that were like 40 feet deep, and then have a light duty pump that would bring them up. And this would be like a mesh that they could have some small fans and do evaporative cooling. So there's lots you can do with very, very, very simple stuff. And, it's kind of cool. But look at how quickly you can get a visualization. This would be a 15-minute visualization, and you can. Now I got to find it. Hold on. I can never remember where to go. Here we go. Where are my face styles? Well, somewhere on here I've got face styles that I can put on here. Not remembering where they go. There it is, materials. So I can put materials on faces, or I can just do surface colors, and I can add colors to surfaces. I can make each of these a different material. It's a little easier in Inventor, but AutoCAD's got the basics for it. And I can set these up to look lots of different ways. You even go, okay, there's my sketchy style. For those of you who are required to make a sketch, you can do something like that, and you go, yeah, I know how to make a sketch. They go, yeah, but that was computer. No, 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 no. That was really, I did that on a piece of paper. I promise. I promise I did that on a piece of paper. And then they go, really? Are you sure about that? And you go, yeah, yeah, yeah. I could even make it not quite white. I could get a little bit of color into it. So that it looks like maybe you did sketch it. So those are just some fun little tools that you can play with. And I know fountain design is really cool, especially keeping a fountain clean design. That's to me what's cool. Lots of people can make fountains, but how to keep it cool. As a matter of fact, one of their neatest ones was at the City Hall in I'm trying to think. I think it was Vacaville, but it might have been Fairfield. And the ripples, so they had like this great big, sorry to go on and on, but this is really cool to me. I love this kind of stuff. So they made like this really long trough. Well, this is a trough, and it was about 40 feet long, and they set it up with little ridges in the bottom, little ridges in the bottom that set up ripples depending on how much flow they were putting through it, which was not a lot. And depending on where you were standing, it was like one of those hologram things. Depending on where you were standing, you would see different ripples. Well, it didn't work so well because algae grew up on all their ripple generators and cigarette butts and pennies and all sorts of stuff. So they asked me to design a little jet scour system for them that they could just hook to their pump, and their maintenance person would just plug in once a week and go through it. Now, since the drought, 10 years ago, they stopped doing it. But it was such a cool thing that they set up so with ripples in the water, you would see a design. That was really neato. I really, really, really liked that one. And I also liked I think there were about 3 houses I helped work on that had water features and a dentist office. The dentist decided to, instead of putting in a fish tank, which he couldn't stand, put in a cool water wall in front of a video. And so he put a very cool little water wall that would sort of spray back and forth across the water wall, the video. Of course, it wasn't across the video. There was a separator panel, and that would be the cooling, and it would be the entertainment for their people who had to wait. So cool stuff with fountains, Anna. Anna, I think you've got some really fun stuff to do. Okay, let me get back to the chat. Any other questions? Okay, so animating the water to show clients, that's really, there's a few ways to do it. The best way that I've seen is in a program called Unity. And you can actually put this in, export it to Unity or Unreal Engine, and they have visual effects, FX generators that do all of that stuff, and it is flipping amazing. As a matter of fact, I could actually show you a guy. You could put this into Minecraft, and I could show you a guy who does shaders in Minecraft that would do that. Flipping crazy stuff. But from what I've seen, the easiest is to put it into a special effects generator. And they're not too hard. I mean, there's tons of good, I call them programmers, but they're animation effects techs. We have some on campus, and you just tell them what effect you want. You could have it a fire burning effect, a water effect, a wind rippling across texture effect. You could have an effect that actually like shattering glass effect. So you would really want to put it into a program that does that, and it's not too hard. So that was Stephen who asked that question. how do you show clients what the waterfall would look like, and what it would look like if it overflowed versus sprayed, things like that. And so it's the summer, I might see if I can get we do have one of our interns who does not work for us for the summer, who is a vendor for the college. And so I might just ask him to do one and show us what it would look like. It's pretty darn cool. And so Stephen, I know you do the pinball machines, right? Man alive. So that's really you. And we'll talk about this. And you might even want to um, become a client of the Design Hub, an external client, where we can develop this capability for you, that you can develop that, because we have some really cool programmers, and all of these actions that you've got, you can place objects that are flippers and give them buttons that flip 45 degrees at a certain rate, and da 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 da. And they have collisions that can tell where the ball is. It's pretty incredible. So you could actually do that in a program called Unity. The other one is Unreal Engine, and we're just learning about Godot. Which is the open source one. You might be interested in programming in Godot, if we get our act together on that. But you could consider pairing up with the Design Hub, either as an internship or as a client, where we would have some interns working for you, which is a pretty fun thing. Be kind of fun. And that is one of our goals, is to support local entrepreneurs who need technical assistance to do the creative job that they're asking for. So you're right up our alley if you're asking for that. So these are really cool things. Any other cool questions? We might have to have sort of a little like fair at the beginning of the fall, where you guys can go, okay, here's what's really cool. Here's what I'd like. And we could show you the closest thing that we've got that we could develop into that. That might be a fun thing. Any other cool questions? Okay, then I'm going to turn off the recording right now.